students. Today we are going to learn about fats and oils. In this topic, we will learn about types, sources, processing, uses, storage, nutritional aspects of all the fats and oils. As you all know, fats consist of a wide group of compounds that are soluble in organic solvents and insoluble in water. They have lower densities than water and at normal room temperature range in consistency from liquids to solids depending on their structure and composition. Chemically, fats are trimesters of glycerol and fatty acids. Although the words oils and fats and lipids are used to refer to fats, oil is usually referred to as a fat which is liquid at room temperature. Fat is usually referred to the one which is solid at normal temperature. Lipids is generally used to refer both liquids as well as solid fats. Cooking oil is a plant, animal or a synthetic fat which is used in frying, baking and other types of cooking. It is also used in food preparation and flavoring not involving heat such as salad dressings, bread dips, etc. Cooking oil is typically a liquid oil at room temperature, although some oils that contain saturated fats such as coconut oil, palm oil and palm kernel oils are solids at room temperature. There are a wide variety of cooking oils from plant sources such as palm oil, soya bean oil, canola oil, peanut oil, vegetable oils, olive oil, safflower oil, sunflower oil and animal based oils like butter and lard. The role of dietary fats and oils in human nutrition is one of the most important areas of concern and investigation in the field of nutritional science. Now let us learn about dietary fat. Generally, a dietary fat includes all the lipids in plants and animal tissues which are eaten as foods. The most common fats or oils are a mixture of triacylglycerols with minor amounts of other lipids. The fatty acids present in various lipid molecules are the moieties of great nutritional interest. Triacylglycerols are the predominant components of most food fats and oils. The minor components include mono and diacylglycerols, free fatty acids, phosphatides, sterols, fatty alcohols, fat-soluble vitamins and other substances. Let us first learn about the major components. Among the major components, we have triacylglycerols. A triacylglycerol is composed of glycerol and 3 fatty acids. When all the fatty acids in a triacylglycerol are identical, it is termed as a simple triacylglycerol. The more common forms, however, are mixed triacylglycerols in which 2 or 3 fatty acids are present in the molecule. Now, looking at the minor components. There are many minor components. The first one is mono and diacylglycerols. Mono and diacylglycerols are the mono and diesters of fatty acids and glycerol. They are prepared commercially by the reaction of glycerol and triacylglycerols or by esterification of glycerol and fatty acids. They also occur naturally in very minor amounts in both animal and vegetable oils. The second minor component is free fatty acids. Free fatty acids are the unattached fatty acids present in a fat. Some unrefined oils may contain as much as several % free fatty acids. The levels of free fatty acids are reduced in the refining. Then we have the phosphatides, which consist of alcohols combined with fatty acids, phosphoric acid and a nitrogen containing compound. Lecithin and cephalin are the most common phosphatides which are found in edible fats. Then we have the next minor component, that is sterols. Sterol, also referred to as steroid alcohols, are a class of substances that contain the common steroid nucleus plus an 8 to 10 carbon side chain and an alcohol group found in both animal fats and vegetable oils. Cholesterol is the primary animal fat sterol and is found in animal fats only. Vegetable oil sterols collectively are termed as phytosterols. Cytosterol and sigmasterol are the best known vegetable oil sterols. Then the next minor component is fatty alcohols. Long chain alcohols are of little importance in most edible fats. A small amount of esterified fatty acid is present in waxes found in some vegetable oils. Larger quantities of these fatty alcohols are found in some marine oils. Then the next minor component is tocopherol. Tocopherols are important minor constituents of most vegetable fats, described as series of organic compounds consisting of methylated phenols, which serve as antioxidants to retard rancidity and as source of essential nutrient vitamin E. Among the tocopherols, alpha tocopherol has the highest vitamin E activity and lowest antioxidant activity. Then the next minor component is carotenoids and chlorophyll. Carotenoids are color materials occurring naturally in fats and oils ranging from yellow to deep red. Chlorophyll is the green coloring matter of plants which play an essential part in photosynthetic process. The level of most of these color materials are reduced during normal processing and refining of oils. Then the next minor component is vitamins. Most fats and oils are not good sources of vitamins other than vitamin E. The fat-soluble vitamins A and D are sometimes added to foods which contain fat because they serve as good carriers and are widely consumed. A traditional source of vitamin A is butterfat. Fish oils are a common source of vitamin D. Margarines which are fortified with vitamin A and D by law in most countries also make an important contribution in ensuring adequate intakes of these nutrients. The next minor component is methylsterols and triterpene alcohols. Sterols methylated at 4-OH position occur in common vegetable oils at concentration of 0.01 to 0.4% with rice bran oil and sesame oil having the highest levels. Then the next minor component is squalene. The predominant hydrocarbon in dietary fat is squalene. It is an intermediate in synthesis of sterol from acetate and it is found in particularly high quantities in some fish and olive oil. The concentration of squalene in most vegetable oils is below 30 milligrams for every 100 grams. Then the next and the last minor component is oryzanol. Oryzanols are compounds consisting of ferulic acid esterified to a variety of plant sterols and triterpene alcohols. Although large amounts are found in crude rice bran and linseed oils, oryzanols are not widely distributed in other oils. Now, let us look at various types of oils and their characteristics. First one is saturated fats. Saturated fats are mainly animal fats and the fats which are solids at room temperature. These fats include butter, cheese, whole milk, ice cream, egg yolks, lard and fatty meats. Some plant fats also are high in saturated fats such as coconut oil and palm oils. Saturated fats raise blood cholesterol more than any other food you eat. By using right oils and fats for right reasons, you can preserve the healthful benefits. Coming to the next types of fat, that is unsaturated fats. In unsaturated fatty acids, there are basically two types, monounsaturated fats and polyunsaturated fats. Coming to monounsaturated fats, these are the fats which usually come from seeds, nuts such as avocado, olive, peanuts and canola. These fats are generally liquids at room temperature. Then we have polyunsaturated fats which usually come from vegetable seeds or nuts like corn, safflower, sunflower, soya bean, cottonseed and sesame oils. These fats also are liquids at room temperature. Then we have the next category, that is trans fatty acids. These are the hazardous kind of fatty acids which are produced when liquid oil is made into solid fat such as shortening or margarine or during hydrogenation. trans fatty acids act like saturated fats and can raise your cholesterol level. There are several types of plant oils which are distinguished by the method which is used to extract the oil from the plant. The relevant part of the plant may be placed under pressure to extract the oil and give an expressed oil. Although most plants contain oil, only the oil from certain major oil crops complemented by a few dozen minor oil crops is widely used and traded. Generally, vegetable oils are classified in several ways, like the oils by source and oils by use. Coming to the by source oils, most of the vegetable oils are extracted from the fruits or seeds of plants, and the oils may be classified by grouping the oils from similar plants such as nut oils. Then we have oils by use. Oils from plants are used in cooking, for fuel, for cosmetics, for medical applications and industrial purposes also. Now let us look at some of the vegetable oils which are generally grouped in different kinds of classes. The major oils are coconut oil, corn oil, cottonseed oil, olive oil, palm oil, peanut oil, rapeseed oil, safflower oil, soybean oil, sunflower oil. These oils are generally used for cooking and other culinary purposes apart from industrial and biodiesel applications also. Then we have the next source of oils, that is nut oils. In these sources we have almond oil, beech nut oil, Brazil nut oil, cashew oil, hazelnut oil, macadamia oil, pine nut oil, pistachio oil and walnut oil. These oils are generally very expensive. They are also used as valued food oils required for different kinds of gourmet and cooking purposes. They also have some medicinal applications like appetite suppressants, etc. Then we have the next source of oils which are called as citrus oils. In citrus oils we have orange oil, lemon oil, grapefruit oil. Usually these are cold pressed oils which are used as flavoring agents and in aromatherapy. Then we have some oils from melons and gourd seeds such as gourds, melons, pumpkins and squashes. Usually under these categories we have bitter gourd oil, bottle gourd oil, buffalo gourd oil, bitternut squash, pumpkin seeds, watermelon seed oils. These are also used as cooking oils and salad dressings. Then coming to the next area or the next topic, that is processing and refining of edible oils. Generally, processing can remove the components of edible oils which may have negative effects on taste, stability, appearance and nutritional value. To the extent possible, processing should preserve tocopherols and prevent chemical changes in the triacyl glycerols. There are different kinds of traditional technologies which are used in many countries for producing oils, which are very important, especially among communities which have easy access to raw materials. Traditional processing tends to be environmentally sound. In the changing industrial atmosphere, these positive features have been outweighed by negative aspects of traditional processing such as small production capacities, poor economies of scale, high expenditures of energy and time, and cost of transporting the oils to markets. And that is the reason why large scale production of oil has come into existence. In the large scale production of oils, the first thing of importance is the storage of oil seeds. Many steps in industrial processing find their origin in traditional processes. In large scale operations, oil seeds are dried to less than 10% moisture. They may be stored for prolonged time periods under suitable conditions of aeration with precautions against insect and rodent infestations. Such storage reduces mold infection and mycotoxin contamination and minimizes biological degradative processes which lead to the development of free fatty acids and color in oil. There are some oil-bearing fruits for oil expulsion such as olive and palm which are treated as quickly as possible. palm is sterilized as a first step in the processing. Now coming to the processing component, oil seeds are generally cleaned of any kind of foreign matter before dehulling. The kernels are ground to reduce size and cooked with steam, and the oil is extracted in a screw or a hydraulic press. The pressed cake is flaked for later extraction of residual fat with solvents such as food-grade hexane. Oil can be directly extracted with solvent from products which are low in oil content such as soya bean, rice bran and corn germ. Then the next step is oil refining. Oil refining produces an edible oil with characteristics that consumers desire such as bland flavor and odor, clear appearance, light color, stability to oxidation and suitability for frying. Two main refining routes are alkaline refining and physical refining, which includes steam stripping and distillative neutralization, which are used for removing the free fatty acids. The classical alkaline refining method usually comprises of various steps. The first step is degumming. Degumming with water to remove the easily hydratable phospholipids and metals is usually the first step. Then addition of small amount of phosphoric or citric acid to convert the remaining non-hydratable phospholipids into hydratable phospholipids is the second step. Then the third step is neutralizing of free fatty acids with sodium hydroxide solution, followed by washing out of soaps and hydrated phospholipids. Step 4 follows bleaching, and bleaching with natural or acid activated clay minerals is used for adsorbing color components and to decompose hydroperoxides. Then the next step is deodorizing. Deodorizing is usually done to remove volatile components, mainly aldehydes and ketones, with low threshold values for detection by taste or smell. Deodorization is essentially a steam distillation process carried out at low pressures and elevated temperatures. Then, coming to the physical refining process, the fatty acids are removed by a steam distillation process similar to deodorization. The low volatility of fatty acids, depending upon the chain length, requires higher temperatures in physical refining than those required for only deodorization. In practice, a maximum temperature of 240 to 250 degrees centigrade is sufficient to reduce the free fatty acid content to levels as low as 0.5 to 0.1%. Then the next step after refining is storing of oil. All oils degrade in response to heat, light and oxygen. To delay the development of rancidity, a blanket of an inert gas, usually nitrogen, is applied to the vapor space in the storage container immediately after production, and this process is called as tank blanketing. Now coming to the next area, that is uses of fats and oils in foods. Fats are the primary constituents of margarines, butterfat, shortenings and oils for salad and cooking. In addition to visible fat contained in the food, fats and oils are found in high quantities in many bakery goods, infant formulas, dairy products and some kinds of sweets. Oils, butter or margarine are sometimes used directly on the foods. The first one is culinary applications. Many vegetable oils are consumed directly or indirectly as ingredients in food, a role that they share with some amount of animal fats including butter and ghee. The oils generally serve a number of purposes in culinary uses like shortening, for texture improvement, for flavor improvement and as a flavor base to carry flavors of other ingredients, since many flavors are present in the chemicals that are soluble in oil. Secondly, oils can be heated and used to cook other foods. Oils suitable for this objective must have a high flash point. Tropical oils like coconut oil, palm oil and rice bran oil are particularly valued in Asian cultures for high temperature cooking because of their unusually high flash points. Then the next application is as cooking oils. The major use of cooking oil is in frying, where it functions as a heat transfer medium and contributes to flavor and texture to the foods. One requirement of cooking oil is that it be stable under very abusive conditions of deep fat frying, namely high temperatures and moisture. Frying oils made from sunflower and safflower oil have lower stability because of their high polyunsaturated fatty acids and low alpha tocopherol content. However, high oleic safflower and sunflower oils that have been genetically developed are suitable for frying oils at high temperatures. For optimal use of cooking oils, it is necessary to distinguish between different frying conditions. The most important parameters to be monitored are duration of use and nature of foods to be fried. If food fats enter the frying oil, food components could destabilize the oil and the water content of the material could influence the frying operation. Then the next application is for margarines. Margarine must have some crystalline structure to maintain a semi-solid consistency at refrigerator and room temperatures. Sharp melting at body temperature is needed so that the margarine will melt rapidly in mouth, leaving no waxy feeling at all. The correct consistency of margarine can be obtained by blending soft and hard fats. Then the next application is as shortenings. Shortenings are semi-solid fats that impart a short or tender quality to baked products or baked goods and enhance the aeration of leavening products and promote a desirable grain and flavor. They coat the gluten proteins of the flour, which prevents toughness. In contrast, toughness is desirable in yeast-raised products to give a chewy texture. For products with characteristics between breads and cakes such as donuts, shortening modifies the gluten and adds richness to the product. In baked goods, shortenings are used specifically to leaven, cream and lubricate. In icings and fillings, the fat help to form tiny air bubbles that create a light, fluffy structure, and shortenings used as stable frying fats provide a heating medium and their crystalline structures are not important. The requirements of fats with properties for shortening are fairly specific depending upon the food in which they are used. For example, bakery shortening should have a wide plastic range as possible, that is, the melting behavior should remain constant over a specified temperature range, often at 24 to 42 degrees centigrade. This quality allows the fat to be easily manipulated without melting at room temperature and enhances its mixing ability. Then the last application is for salad oils. A major use of salad oils is in pourable salad dressings. Traditional salad dressings, some of which are emulsified, consists of a two-phase system of oil and water with 55 to 65% oil. A salad oil coats the salad ingredients, spreading the flavor of the dressings that improve the palatability of the salad. The other major use of salad oils is in mayonnaise and thick salad dressings, which contain 80 and 35 to 50% oil respectively. The oil in mayonnaise is responsible for viscosity, whereas the oils in thick salad dressings help to modify the mouthfeel of the starch paste that thickens the product. Then we have the medium chain triglycerides, which are common dietary fats and lipid fractions such as medium chain triglycerides. These are generally used in specialized therapeutic preparations. Medium chain triglyceride oil is a fraction of coconut oil containing fatty acids of about 8 to 10 carbon atoms in triacylglycerols. Medium chain triglyceride oil is used in formulas for enteral feeding and in diets for patients with malabsorption syndromes. Then we have the hydrogenated oils. Usually, the unsaturated vegetable oils can be transformed into partial or complete hydrogenated oils of higher melting point. The hydrogenation process involves treating the oil at high temperature and pressure with hydrogen in the presence of a catalyst called nickel. An oil may be hydrogenated to increase resistance to rancidity or to change its physical characteristics. As the degree of unsaturation increases, the oil's viscosity and melting point increases. While full hydrogenation produces largely saturated fatty acids, partially hydrogenated fatty acids results in transformation of unsaturated cis fatty acids to trans fatty acids in the oil mixture due to the heat used in hydrogenation. Partially hydrogenated oils and their trans fats have been linked to an increased risk of mortality from coronary heart diseases among other health risks. Lastly, the industrial uses of oils. Vegetable oils are used as an ingredient or component in many manufactured products. Many vegetable oils are used in making soaps, skin products, candles, perfumes, and other personal care and cosmetic products. Some oils are particularly suitable as drying oils and are used in making paints and other wood treatment products. Vegetable oils are increasingly being used in electricity industry as insulators, as vegetable oils are non-toxic to environment, they are biodegradable if spilled and have high flash and fire points. Vegetable oil is being used to produce biodegradable hydraulic fluids and lubricants also. Some vegetable oils like castor oil have been used in medicine and as lubricants for a long time. Castor oil has numerous industrial uses, primarily due to presence of hydroxyl groups on the fatty acid chains. Castor oil and other vegetable oils which have been chemically modified to certain hydroxyl groups are becoming increasingly important in production of polyurethane plastic for many applications. These modified vegetable oils are known as natural oil polyols. So today we have seen about what are oils, the various types of oils, the various sources of oils, the types of fatty acids, the major and the minor components in fats and oils, and the uses and applications of fats and oils. So finally, to conclude, the range of food uses requires a variety of fats and oils with characteristics tailored to meet all the needs required for human diet. Efforts to modify the consumption of fats and oils may be limited by various technical requirements, and that is the reason why many other types of oils from the regular vegetable oils such as margarines, hydrogenated fats, etc. are being made for various applications in the food industry.